All right, so we're back for week two. So sorry about last week's video. I didn't notice that there was a watermark on it until like 48 hours after I posted the video. I thought the program or the editing software I was using, it said that I had free for a week that I could export this for free without a watermark, but turns out that I only had like a week free to export it, and I didn't even have a choice whether there's a watermark on it unless I pay. So, but anyways, that's not going to be a problem anymore because I'm just going to record straight off of OBS. So, what happened this week? This week I looked at machine learning. Uh, well, obviously, but I mean, I went through week one of this course on Coursera, and I went through just week one because starting week two, he's starting to use a program called Octave, and I was trying to focus purely on Python at this point. For the first, I'd say month or two, I definitely want to just be exposed to Python as much as possible. So I didn't really play around with different programs and different libraries. Stuck with Python. And now, what happened was I actually ended up buying this course on Udemy. This is by Jose. It says Python for Data Science and Machine Learning Bootcamp. Yeah, it's by this guy named Jose. I don't know. Let me see where this does it say. Does it show where he is? Oh yeah, right here. This guy right here. Yep, this is by him. He explains. I like the way he explains things because he kind of gets to the code pretty well. But the only problem is if you are interested with behind like the statistics and the math behind some of the like machine learning algorithms and some of the stuff that he's doing, that's not really covered because if he does cover that, I feel like this course would be very, very long. Um, but other than that, I think it's done very well. I'm getting a lot of exposure. Um, it was like what I think Udemy, most of the courses are like $10. So I think I have another course because I'm kind of like playing around with the courses. Let's say I didn't understand one thing from this course, then I can jump over to the other course, right? So total I spent $20. I didn't think that I would spend money on like some courses, but turns out like not gonna lie, these are some worthwhile investments for $10, especially for someone that's like super new in the field. Anyways, let's jump back to what I've learned specifically this week. Right. So we talked today or this week we I mostly focused on or starting off in the beginning. I was introduced to supervised and then unsupervised learning. Learning, and this is learning. Okay, so supervised learning, you can have kind of two different groups. Where supervised learning, it means that you're going to feed in information to the machine and you're going to tell the machine there's a correct answer, meaning that the data you give it is complete. Like let's say I give you a bunch of variables for house prices, and then I ask you, okay, now give me the price. But when I'm feeding into it, I actually have a correct price for that specific house. And the unsupervised learning is a little different where I think it plays with the idea of clustering where there's no exact answer, but the machine can kind of cluster it into something and then decide, okay, it's going to belong in this cluster. That's why like this is the answer or something like that. Okay. So supervised learning has two different types. There's classification and there's also regression. Okay. So classification just means that you're going to they're answering two different types of questions. Okay. Classification is answering a discrete usually discrete variable. So meaning, let's say I ask you, um, is is this house considered new or old? There's a very specific answer, right? It's new or it's old. There's no the machine is only going to give you one of the two answers. And then there's also I guess an even better question example rather is from what I've seen is people like to use, okay, is the email considered spam or not spam, right? When you get an email, is the machine going to recognize it and say, okay, this is spam, or is it going to say this is not spam? That's kind of what classification means. It's like a yes or no. I think that's the easiest way to think about it. It's yes or no. So like it's true, yes or no. Regression is a little different. You're predicting something that's continuous. And I think the best way to do this is price, right? Where we talk about the housing, and this we can just say, like, we can even think of this as a true or false. So regression, continuous like price. So for example, let's say, like I said, the house prices. Let's say I give you a bunch of variables, maybe the number of bedrooms, the number of bathrooms, and then the square footage of the house. Can you tell me what the price is? And I'm also feeding it. Obviously, because this is supervised learning, I'm going to feed it the correct price for that, for the training set, and then I'm going to give you. It's going to spit out a different value after it trains itself. Okay, so hopefully these two make sense with classification and regression. Unsupervised learning is a little different. So there's clustering, and then there's also, I think it's called dimensionality or dimensional reduction. I think it's dimensionality actually. Let's just take a look at this. Yeah, this dimensionality. I'll go over that in a second. But dimensionality reduction it usually leads into the playground of PCA, principal component analysis, which I had some exposure to this in like a statistics course, but not too much because I didn't really understand it super well. And clustering is kind of like the idea where, let's say I have a bunch of this and maybe some data right here. Then I can say, okay, this data is grouped right here and this data is grouped right here. But there's no correct answer. Like the machine wasn't told that, okay, this means true, this means false. It's just going to group it with this category. Right, so that's kind of, what I started off my week to. So moving on, I want to talk about linear regression, a very specific type of supervised learning, rather. It's linear. And I'm going to actually introduce linear or multiple regression here. And the simple way to put the difference is basically linear regression is I have one input, okay? I have one independent variable that leads to one dependent variable. Well, all of them is going to lead to one dependent variable. So I have, let's say for just the house, I only have one variable I collected. I collected the square footage and I got the price, corresponding price with it. You can think of this as a 2D graph where I have this, where this is the price, and this is the square footage, square feet. And then you can kind of have like some data flowing around here, and you can see that generally the bigger the house, the higher the price generally will be for that specific house. That's linear regression. I have one input right here. Now, multiple regression is not far from that. It's basically saying, let's say I add another variable. So it's two or more variables. And now I have price on here. Let's say I have the number of bedrooms here. Number of bedrooms, and then this is still square footage. So now I have some data plotted like over here. And then I can draw another line like through here. Sorry, kind of overlapping. I'm not super good at drawing in 3D or trying in general. But we basically have multiple inputs now and it's trying to draw a line to predict a price. Okay? So that's the two differences between there. And linear regression, what's going to happen is there's something called a gradient descent, and specifically for linear, it begs the question, how do I know that this line is the best fit line? Or how do I know that I can't draw a line that's better that reduces my error? And how it works is I'm trying to minimize the distance from that one line, from like this 1 point value to the line right here. And I'm gonna think about all of these drawing here, 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 all of these points drawing down here. And I want to say, okay, I want the minimum of this. So basically you want the minimum of the sum of I equals 1 to n, and then this is, I guess we'll do yi minus y bar, which is the mean, squared. And actually, this is not y bar, but rather this is actually the function that I'm going to put in, okay? So we want to minimize this function. How do we minimize this? This is where like the idea where we can use gradient descent, where because it's a linear model, what's going to happen is, let me grab an eraser right here. Because it's linear in a three-dimensional sense of things, it's going to look something like this. Let's say I have something like this, this? It's gonna have this bowl shape, and I'm not sure if I can draw this very well. It's gonna have this bowl shape, and essentially, it will constantly change. You know, let's say I pick this point, pick this point. I think if you are really interested in how this works, there's his video on gradient descent intuition. This right here, parameter learning, it explains it super well. But I'm just trying to do a quick little explanation. But basically, for linear models, linear regression specifically, there's always going to be this local minimum. This local minimum is also the absolute minimum. Okay, there's only going to be one minimum point. So no matter where you draw, whatever you descend from, it's always going to go lead to this point. So this is the point that is going to fit your line the best, where this is a function of both your intercept and your input value. Okay, so that kind of covers a little bit about linear multiple regression, but I want to talk about something else that was extremely interesting to me was specifically, actually, let's just clear all. Where you would think most of the variables that I input into a regression model, or linear regression specifically, is that they're going to be continuous values, right? So let's say, for example, I put in the square footage. The square footage is as a continuous because that value doesn't really. There's really no like distinctive way to determine. I guess you could group them and categorize them into like large, medium, or small, but generally square footage has this continuous value and it corresponds with the price. But now linear regression actually is very flexible in that it can take in classification variables. What I mean by that is, let's say we also have an input like a column. So let's say this is their square footage, this is one column, and then we have something like old or new, right? And then we have something called price right here, which is reflected. And then you just have these values right here. So if you notice, this is continuous, but this is a discrete, or this is a classification variable, right? We're essentially in this, well, I either have old, or new, right? And you can't really pass those values in to a regression. The regression needs to take in numerical values, right? So that's where the idea of a dummy variable plays in, which I think is a super cool concept. Let me just show a quick picture right here. And this kind of shows like west, south, and north. You'll notice how these are the different classifications, but all of these have the same slope. Okay? I'm going to try to explain this without a lot of math. I'm going to try to explain the intuition behind this. So basically, it's going to fit two different lines, all right? So let's say I have this line and I have this line. Generally, you would say the newer houses are probably more expensive than the older houses. Obviously, there are exceptions here, but we're going to ignore that. So we have a new and we have an old. What this dummy variable is saying is it's used by 0 and 1s, but I'm not going to go into the math behind it. But what's going to happen is it's going to generate two different lines into your regression. All right, it's going to be old or new. So the program recognizes this. It's already created this. It's in this database. Now, whenever you pass in, let's say a new one. So this is let's say your training set, and now we have your test set. Now our test set, we have that it's actually an old house. So when it recognizes it's an old house, it's going to start looking at this specific line and try to match it accordingly with the square footage. So this is still square footage and this is still price. So we're going to pass in, let's say I find this old one, it's an old house, it's going to pass it, it's going to go into this specific line and find a value on this line. Okay, but now instead, let's say the test set also has a new house. Now it's going to go up to this higher line right here, new. For new houses, this is the line for only new houses. It's exclusive to new houses. And just like this line is exclusive to old houses, this new line is going to find a value. It's going to fit it onto this line. All right? It's going to find a specific value on this line. So basically what I'm saying is, let's say our square footage is 5,000 for both of them. All right? So in a way, I'm holding all else constant except for whether it's new or old. So let's say the square footage right here is 5,000, right? So then this line, if it's old, it's going to predict this specific price point. If it's new, it's going to actually just shift up and it's going to specifically predict this price point. You'll notice that these two are supposed to be parallel, but these two slopes are always going to be the same because it's a linear regression. It's the same line, it's just shifted to a different location, depending on the different parameters. I can introduce actually multiple, more than just old, new. I can say old, new, or like medium, not really old, not really new. All right. So that's why um, classification isn't just limited to two. It can be three, four, five, however many that you want. But you just have to introduce different columns. That's when the math starts to get a little more heavy, and I'm not going to talk about that. But hopefully this makes sense. Where basically, you have two different lines exclusively to the new or the old, and from there you can use the line to predict the house price. So moving on, we talked about that. Um, I thought this chart was super cool because it's kind of sklearn, or the scikit is basically the most popular machine learning program on Python, and it kind of gives you a little cheat sheet on which way to go. With whether you use classification, regression, dimensionality reduction, or clustering, and it just moves you into the little categories on what you should do or not. I thought this was just a cool diagram. But finally, the last thing that I really learned this week was, um, or actually no, I also learned about plotting on Seaborn. I remember last week I talked about how Seaborn and Matplotlib, those two programs were just way over my head, but this guy explains it super well. I was comfortable with Seaborn. It's really not too bad. It's like the command is kind of just like put into place, and you just have to input the data the correct way. It's not too bad. Honestly, I could have probably done it without the course. I think I just was not interested in graphing and plotting, but uh, when you plot on Seaborn, with just a few lines of code, you can do a lot with it because you are able to see so much without typing like a ton of code to where I have to like group by and all that stuff just to see certain data. But obviously, a pictorial view of something is always good. It always helps me. So Seaborn is definitely a must learn, especially during presentations. If you want to present it to somebody, they're not going to read your code and stuff like that, right? They're going to want, if you're going to present something, it's going to be like usually with charts, and then the numbers follow afterwards to like coincide with one another. Finally, the two other algorithms that I learned about was logistic regression and what's it called? Logistic regression and KNN, kth nearest neighbor. Um, so with linear regression or linear slash multiple regression, I don't know why my M's look like this. Multiple regression. You'll notice that this is a regression technique, right? We're using this to predict a continuous variable because, well, it has the name regression into it. But with logistic regression, we're actually predicting, it's actually not a regression technique, even though it has regression name into it, right? It's actually a classification technique, meaning we're trying to predict like if it's true or false. And finally, with KNN, kth nearest neighbor, this is also a classification technique. I'm not going to touch too deep onto these two because I just learned these, and I'm not going to like pretend I know something I don't. Um, these are quite these are still a little rough for me. I understand how to apply them obviously with Python. It's not super difficult because sklearn kind of scikit just kind of does it for you. But the math behind it and stuff, I still need to look into and understand why exactly this works, right? It's not just important to know it's not important to just know how to do it, but rather why this works. So then you can pick which technique to use. That's why I thought that this graph was super cool, where you can kind of like, let's say you're not super sure on what to do, then this kind of points you to the right direction, right? And finally, the ultimate thing I learned this week was that a lot of what I've been doing and the machine learning is not the difficult part. Applying the machine learning code and, you know, and finding a specific value, or let's say making a specific prediction, is not the difficult part. It's the organizing of data, right? Where I have to manipulate the data to put into to feed into my machine learning algorithm. That's why I talked about, the dummy variable a little bit and where you change things. But that is pretty much it for this week. I don't think I have anything else. But next week, going to revisit the Titanic project, I think. And yeah, I'm going to revisit the Titanic project and definitely do another project. I think this is called the housing regression project. I'm going to do that one. I'm going to try that myself and then obviously look at some other solutions and try to maybe help myself build into that. But that's it for this week. So I'll see you guys next week.